Hello, Igor. Nice to meet you.
Nice to meet you.
Welcome to Sydney.
Thank you so much.
And then thank you for visiting our customers and who had the system which installed last year. Is the customers happy about using your system?
I'm very happy. We have been using the system to see the uterus of the mouse, and it was quite successful. We used 10x objectives and one of the objectives with 20x of magnification that you provided.
Great, great. Thank you for looking after the customer with us together. We also have a support team here to look after the customer. Really happy. And I've also heard that you managed to install your latest Lightsheet product in New Zealand. How does that go? And also, what's the difference between these two systems, the new technology and the system in Sydney?
Yeah, exactly. Last week we spent with the customer while installing our latest newly developed system called Alpha 3 Facility Edition at the Facility Edition of the University of Auckland, wherein we are talking to researchers of very different backgrounds and handling different kinds of samples ranging from small spheroids to mouse brains. So the microscope we installed is especially designed to meet specifications of requirements, rather, of different groups of researchers.
Also, that means it's very suitable for the core facility.
Exactly.
Okay.
And everyone can have access to this instrument before their measurements and return back to those measurements to the same settings of the instrument which it had a while ago. So this way, the instrument will can provide with the very repeatable results. At the same time, the results suitable for a large majority of users of the facility instruments.
Oh, that's great to know. Do you have a presentation to show us some details then?
Yeah, first of all, I would like to talk about the basics of the light sheet microscopy in general. As you know, the light sheet microscopy is based on shining light upon the sample from several directions and recording the emitted light from a preferably perpendicular direction to the illumination beam, and whereby a high optical sectioning is performed as a comparison with the confocal microscopy is very well established techniques. One of the very well established techniques, the acquisition speed of the light sheet microscopy is 50 to 100 times greater, and the signal to noise ratio is 10 to 100 times higher, while photobleaching is up to 3 orders of magnitude lower. In the actual resolution of the light sheet microscopy, as you know, is roughly similar to confocal, to that provided by confocal microscopy. The literal resolution of the light sheet is comparable to the that of a wide field fluorescence microscopy. The per sample imaging can be achieved with light sheet microscopy based on the fact that the longer working distance objectives are used. In our company, we are manufacturing for almost a decade a Alpha 3 light sheet microscope, which is based on using light sheet illuminators around a standard microscope stand and the camera attached to it.
I can see that is our BX43.
Exactly. It's this is the microscope which is very well suited to light sheet imaging because it has a very nice geometry, nice architecture. It has oculars, it has a very small footprint. It has everything that a light sheet microscope can be proud of, including the possibility to provide a transmitted light in order to locate the sample prior to imaging it with a high-end Olympus evident objectives like the 10x, 20, 40, 60, 25x for several mediums, including water, clearing mediums, and the user of this microscope can observe the sample through
From the
eyepieces,
eyepieces
from the
easily.
eyepieces easily,
I see.
because there are notch filters inserted in the optical path of detection optical part to preclude users from damaging their eyes.
Oh, so their
Yes.
laser safety is also
Yes,
included very
all-
well in the system.
Yes, the laser safety is of paramount importance there, and we insert special filters to cut off the laser light incident on the sample.
That's great.
The system has a front-loading sample holder and imaging chamber, and it has dual light sheet illuminators to provide a homogeneous illumination of the sample. The bright field and fluorescent optical section are visible from eyepieces, and the laser light is provided to the system via through the use of the laser combiner, which can be equipped with up to 6 lasers. The emission, the illumination wavelength of each laser can be from 405 nanometers to 785 nanometers.
785. So now it means that the applications is really moving to the near IR
Yeah.
window.
Yes, this instrument in fact can cover a large range of applications, a broad range of applications.
That's good to know.
And
Yeah.
we use a highly high resolution scientific CMOS camera, and the fluorescently labeled samples are inserted in a special design chamber. The system has a modular architecture. It can be upgraded with optional modules to ensure that the researchers have all the tools to handle samples with. And the system is capable of imaging any kinds of samples, from in vivo sample to clear samples of whole organs and very tiny small organisms. Laser lights are provided to the system, and the system is capable of providing laser light sheets from simultaneously from up to two directions. This system achieves the resolution of about 0.75, 0.8 microns, which is lower, smaller than 1 micron.
That's great.
And this architecture results in sharp optic and sectioning of this sample in artifacts free imaging and homogeneous resolution throughout field of view of the camera and in ultra fast scanning.
I have a question here.
Yes.
So I can see that it looks like the chamber is equipped with a incubator as well. Would you please give some details on this?
Yes, we for every chamber with that is used to host the sample holder, we design a special incubator that fits each and every chamber we use. And we can have sample chambers of different sizes, like this one chamber, which is fit for imaging small size samples. And the incubator can be used to maintain the temperature, humidity, and gas conditions necessary to maintain a sample in life.
Okay, that means that this system is also able to accommodate live samples like
Exactly.
zebrafish. Like
For
cells.
example, like zebrafish samples.
Mhm.
And we usually embed such put these small living samples in specially designed wells in agarose or feeder gel, as well as simply by putting a drop of agarose on top of the living sample. And
good to
then
know.
the objectives are very easily to access, very easily to change, to select the good objectives for your application. And the objectives has no physical contact with the sample.
Okay.
All kinds of objectives normally used in biological imaging can be all as well used in light sheet imaging with our Alpha 3 light sheet microscopes, such as water, air, clearing detection objectives. The objectives with a correction color, such as those provided by Evident.
Yes.
Especially for 10x objective and 25x objective, which are customarily used in our in detection part of our microscope. Large choice of detection objectives allow us to switch from the macro view to micro view. As to give you an example, we use water deepening objectives ranging from with magnifications ranging from 10x to 60x, and clearing objective with magnification of 10x and 25x. We use multi-photon longer working distance objectives as well, equipped with correction colors. As to provide the researcher with a micro view of the entire sample, we use 2x and 4x objectives to give an example. In this modular architecture, there's a room for several useful technologies like laser focus sweeping, image XY tiling, fast 3D scanning, incubation, and motorized sample rotation. The samples of various sizes and natures can be put in sample chambers, and the sample chambers can be conveniently adapted for each specimen. The purpose of our sample holders and the ways in which the samples are put onto these sample holders was always to maintain specimen integrity and physiological conditions of this sample. Here we have a slide which is devoted primarily to mounting a plant sample on top of the sample holder while embedding those plant sample in a agarose gel.
Agarose gel, yes.
Here we also can handle a very large variety of the samples, like in spheroids, which can be put on a simple slide. Yes, and this slide can be rotated to present the good side of the sample to the detection. And the mouse brain can also be put on top of the sample holder while maintaining this mouse brain with clamps, specially designed Teflon clamps, which sit firmly on the glass support.
Okay, I have a question here.
Yes.
So normally for this whole tissue, like the cleared brain tissue, what's the chamber will be used, and what the typical objective for illumination and imaging will be applied? To image the whole of the brain, we will possibly use 2x or 5x objectives for illumination. Oh,
And then we'll stitch several stacks of created stacks of images to get the full picture at low mag, while also using 2x or 4x objectives in the detection side. At the from the detection side of the system, and then there is also a possibility to go to a very fine to image a very fine structure inside the let's say mouse brain, which was previously imaged with 2x or 4x objectives. So in this way, the same sample, same big sample can be measured, can be imaged in the same setting with the objective with the low mag, and then with the high mag as well.
Okay, okay, that's great to know. So you are across the from a macro images and then switching to a higher magnification objective to acquire the high resolution imaging.
Yeah, with the same instrument.
With the same instrument.
And that you know that we are very the system is very flexible as far as the usage of the several objectives is concerned. We use evident objectives ranging from 2x to 6x.
Wow, this must be the new feature of the latest system, right?
Yes, this is the new feature of the latest system is that those objectives can be switched automatically.
Oh, that's
yes,
great to know.
It's a very nice experience wherein you just switch between objectives without actually touching them.
Wow.
Instead of something which you are accustomed to, like changing the objectives manually. The system can select the right couple of objectives from the illumination side, from the detection side, automatically, or at least manually, or at least provide you with a motorized solution without touching this the objectives themselves.
And then I guess in this case, once you pre-align the system really well, it's also be an easy switch from the lower mag to the higher mag.
Yes.
Without need to realign everything.
No, there is no realignment needed, because we use specially designed calibration targets prior to operating the system, prior to giving the user the possibility to operate the system. We when the system is firstly installed, we calibrate the system by using these the calibration target, which in fact you can notice on the rightmost picture next to the zebrafish sample. So the calibration target can be installed next to the sample itself.
Wow, that's quite convenient.
Yeah, it's very convenient because we have a very long supporting glass upon which we can place samples.
Okay.
And the configuration between the geometrical configuration between the chamber and the objective stays the same. It's only the holder that moves inside the medium. Inside the chamber.
Okay.
So the chamber doesn't move at all.
Oh.
In the new developed system, in order not to interfere with the optical paths from the illumination side and from the detection side as well.
Okay.
And so there is no realignment, hardly any alignment, so to speak, is needed to image the sample, apart from the realignment, which could be caused by temperature fluctuations inside the facility.
Oh, so that means that the environmental conditions is also quite.
Yes, but
crucial, like-
they can be accounted for by the automatic nature of the system. So the system automatically, or at least by using motorization, can be realigned very quickly to meet new updated temperature conditions
Okay.
within the core facility.
Oh, that's amazing. Yeah.
And so that's why the samples can be of very very large variety.
Oh, yeah.
And the system can cope with a cleared, fixed, or live samples, small and large, for a wide range of applications.
That's great to know. Oh, I can see this is one of the largest sample applications.
This is a zebrafish. It's not the largest,
Oh, it's
but
not the
it's
largest.
still a small sample for this system. But still, yeah, the user given with the system the users in the core facility can handle all kinds of samples from very small to very big. All those samples, sample chamber can be filled with special fillers, inserts to spare mediums employed to host the sample.
Host sample, yeah.
For example, these samples can be put on glass cover slips, like in this case, a mouse retina, maintained between clamps, specially designed Teflon clamps, and then put to be imaged as here in the on the right image. There is a 3D reconstruction of imaging of the mouse retina, made with 5x illumination objective and 4x detection objective. As you see, the sample imaging is isotropic so we provide this instrument can provide the isotropic imaging of the sample.
Beautiful.
Clearing is very important in light sheet imaging. We handle we work with very large variety of imaging clearing protocols to accommodate mediums of different arrays.
Yeah,
and
yeah.
in this respect, the evident objectives
The multi-photon
equipped with the correction color, including the 10x objective with multi-photon imaging, is a very nice choice of ours. Is a very good opportunity for us to use those objectives in our microscopes.
Yeah, we are very proud of this superior optics with our multi-photon dedicated objectives. They are long working distance and have a correction color to covering the whole range of the.
And the long working distance is very of paramount importance because light sheet imaging, as you know, is geared toward imaging of volumetric samples. And one of the limitations of this kind of imaging is the working distance of the detection objective, and we use the working evident objectives having a large working distance because of the capability to image deeply inside the sample, and the clearing allows us to do so because we can go deeply inside the sample.
Yeah, that's the amazing part of the light sheet
Yes,
system,
it's amazing part which we can cover a entire sample within minutes while using evident 10x objective, multi-photon objective with correction colors. So we can with the same objective, we can look at the sample while when it is embedded in water, in clearing solution, we can protect the if needed, this nice objective can be protected with the Teflon part that separates the aggressive medium from the objective itself. And the samples can be maintained firmly with Teflon clamps, and all the parts here in the system are made from stainless steel, medical stainless steel.
Okay.
And some samples can be maintained with special design clamps. One of the great applications of this kind of system is imaging large samples. Like here we have a large sample in cubic imaged with our microscope and with the with 10x objective.
Oh, that's the one.
Yes,
the
yes.
Yeah.
And then to host samples, we designed several sample chambers of several geometries of several sizes, ranging from 250 of several volumes of liquid, of medium spent per experiment.
Okay.
To host large samples, we can use a sample chamber of the volume of 250 milliliters, and our smallest chamber possible is about is of the volume of about 10 less than 10 milliliters, and all these chambers are compatible to clearing protocols, to resistant to corrosive media. They are prone to be reused. They are reusable, and they are quick and simple cleaning. If you break a window in this sample, you can easily replace it on site. Yes, by the user on site. Okay. You are not asked to purchase another chamber. In fact, they use a simple glass slides of 0.18 millimeter wide glass slides. So and then to preserve these samples in the living environment, to offer these samples with the environment which protects them from dying, the special incubation enclosures were developed. Okay. And we can put every sample chamber which we developed inside the special design incubation chamber. Yes. And large choice of clamps and molding forms is also available, with supports for cover slips and glass plates. The clamps can be put on the sample, on the glass sample holder. The Teflon parts are of different forms to accommodate different geometries of this sample.
If a customer has a request of a type of mold or different size of the support, are you able to customize for the customer?
Exactly. All those Teflon parts shown here were inspired by customers' requests.
Oh, okay.
Every one of those holders were inspired by customers' request. The sample can be maintained in a different orientation. The position of the sample can be checked prior to putting it in the solution. Forming molds are provided to make special molds from Fitogel and agarose. And usually the procedure with which the small sample is put into the system is as follows. First, a Teflon cylinder is put on top of the holder, and a drop of agarose or fita gel is put inside the Teflon part
Mhm.
to form a cylinder in which a hole is drilled with a separate Teflon part. And in this so created well, the sample is put together with the liquid,
Okay.
together with the liquid, uh, in which the sample has been developing itself. And this the entire structure is kept with the drop of agarose, so the sample will not escape from it. In this way, the sample is maintained in its physiological condition in which it was developed,
That's very interesting.
and the sample can be put inside the microscope easily with the and be rotated such that it presents a nice nice side to the detection optics. Larger samples can be put with the clamps. And speaking about technologies involved, the technological development of this machine dates back to early 2010, 15, and we were always working toward maintaining a large numerical aperture from the illumination side. Vertical numerical aperture and horizontal vertical aperture are very large in our system, so the system is capable of providing a very tiny, a very thin optical, very thin laser waste in the
light
of the
sheet.
laser of the laser beam
Mhm.
presented to this sample, whereby maintaining a large numerical aperture from in the vertical and the horizontal direction, resulting in a very fine optical sectioning, very result, very high-res optical sectioning.
Yeah, I can see this is extremely useful when you're using the high mag, high-NA objectives.
Exactly.
The focusing on speed.
Yes.
Well, yeah.
Yeah, exactly. And with the, for example, lasers focus sweeping, we achieve a homogeneous, very highly resolved imaging throughout the field of view of the camera, which can be big compared to the size of the waist of the laser beam.
Laser beam, yes.
We use the CMOS camera with the rolling shutter to maintain the synchronization between the focus sweep and the rolling shutter of the camera.
Okay, I have a question here. So in the software, is there a option or is there the setting you choose to use or not use?
Exactly.
Okay.
There is an option to use or not use this kind of technology. If the customer is mainly concentrated on the center of the image, or the sample is very small with respect to the entire
illumination
and entire detection of the objectives from the illumination and detection sides respectively. It's a little bit on overshoot to use this kind of technology because the area covered with the detection and illumination covers perfectly, matches perfectly with the sample size. However, if you are like in this slide, measuring a large mouse brain, wherein the entire mouse brain should be imaged, irrespective of the position of the pixel of the camera. For example, we need to measure not only the center of the mouse brain, but also the portions that are located in the outskirts of the image. We need to use the laser focus sweeping to enlarged to make the image the imaging of high resolution as large as possible,
Yes.
and at least covering the entire field of view of the camera.
Okay, yeah. That's a very cool technology.
Yes,
Yeah.
I agree. And here is it is exemplified with the imaging of the large
Significant difference I can tell without
yes, and with
yeah.
again, if the user handles large samples, it's very useful technology.
Okay, yeah.
Making use of the ability of modern cameras to provide a rolling shutter
To synchronize.
sweep inside their cameras. Also, it is visible in images of 3D images that every part of the image is reconstructed to a finest resolution possible, and the resolution stays homogeneous throughout the 3D stack of the images. In turn, this allows to use the convolution algorithms with the especially invariant ESF.
Amazing.
This is a mouse brain image.
Yeah.
With the technology. Of course, this allows in turn to tile images because in this case tiled images feature the same resolution in the center of those images and in the at the size of the images. Also widely used is a fast scanning technology, allowing us to acquire at the camera speed all those images with something occurring in the sample at a very high rate.
High rate, say like if the sample is moving.
If the sample is moving, or there is blood flowing inside the sample, or cells are dividing very, very quickly. Something which is a very on a time scale very quick to occur. For example, like 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 the imaging of the macrophage here made at the camera rate of 75 frames per second, and each stack contained 20 slices.
Oh.
So in this way, if the sample, for example, is embedded in a agarose cube, any slight movement of this cube leads to a sample vibrating.
Oh.
So to preclude this from happening, the remote focus, dynamic focus, technologies are very useful because they will ensure that the sample is at rest while it is being scanned, in fact.
So I have two questions.
Yes.
Is there a for the dynamic focus, is it what type of the technology? Is the hardware or is also combined with the software?
It's both. Mainly it's a synchronization between the galvos mirrors and the liquid lens.
Oh, okay, yeah.
Liquid lens changes the focus of
at very high rate.
At a very high rate.
Okay.
At a very high rate. At least this technology is not hindered by the rate with which the focal distance can be changed with liquid lens. The main limitation is the frame rate of the camera itself.
Oh, okay.
So the focus can be changed very quickly in sync with the galvo mirror movements.
Oh, yeah, that's very cool.
Like here, so this is also important to colocalize images, provided with several channels.
Yeah, you mean multiple colors, and
yes.
then they will have a chromatic in the Z directions.
Even if a very nice objective is used, like like evidence tenings, multi-photon objective, there will be some residual.
That's the nature of the
Yes.
illumination light, right?
Yes,
Mhm.
there will be some residual chromatic aberrations, and that will result to will lead to collecting light from several detection planes. And to localize imaging, a special technology called dynamic focus technology is used that consists in synchronizing the position of the light sheet with the position of the focal plane detection objectives. Like in this case, the merging was performed of emissions resulting from shining light of wavelengths 488 and 561 nanometers upon the sample. And when the dynamic focus is used, the good localization manifests itself in a very sharp image containing both responses from 488 and 561 channels.
Is there a limitations on particularly wavelength to be corrected, or all the 6 lines can be corrected with
all the 6 lines can be corrected?
Wow.
And the correction can be put in place prior to measuring, prior to imaging the samples with the special calibration tool which we developed. Because this calibration tool can provide light resulting from several channels.
Okay, yeah,
same time.
that sounds great.
And here comes the software, which is a very which is instrumental in developing this technology, because the software should be easy to use.
Very simple.
Very simple software.
Very user-friendly interface.
The user can select objectives. They can select exposure time of the camera, select lasers, select emission filters, select the number of images in the stack or distance between images, select the position of the image, select the rotation angle of the sample, and select to use or not the sweeping, laser sweeping, and the range of the sweeping.
Okay.
And the samples and the images are saved in the as a 16-bit TIFF images together with metadata. They are the images can be handled with several third-party software.
Say like MRIs, be able to stage and then do a 3D view rendering.
Exactly.
Okay, yes. So normally I have a question.
Yes.
So what is the data size range? Because when dealing with the light sheet technology, and I think we are dealing with a huge amount of
data. Yes, right. You're correct. And we are talking about terabytes.
Okay. Yeah, so we need to have a good storage of the computer, as well as what is technology you wanted to easily transfer or archive the data.
Yes, exactly. So we provide the special solution called hybrid imaging, hybrid storage and processing units that is capable of storing data in it, and is good enough to visualize data with several packages like Imaris.
Okay.
So we can list a lot of applications which can be covered with this kind of technology. We can spend years to talk about applications which can be covered. We are talking about plants, applications from plants to living tissues, living samples, spheroids, mouse brains, uterus, whatever. A lot of application can be covered. A lot of application can be that they're covered with the confocal microscopy. They are also covered with the large microscopy.
But with a much better improvement on the speed
Yes, much
Yes.
better improvement on the speed, on the photo bleaching.
and the possibility.
Yes, and also with the capability to image sample in the volumetric samples.
Yes, yes.
And when we are speaking with the community with the core community, they are all all kinds of people are using the core facilities. And these researchers have different applications in mind, have different
Use different, especially using instrument in different settings among users.
yes,
Yeah.
each application calls for a different setting.
Yes, that's true.
Because large is a technology in which there should be a good understanding of light propagation inside the tissue, inside the volumetric sample. A good knowledge about the temperature conditions, environmental conditions in the room, and about the geometry of the sample itself. So each and every researcher will come up with their own strategy, and to cope with it's a multitude of researchers inside the core facility. We developed a Alpha-3 facility edition system, which provides the user with the automated multi-scale imaging capabilities.
Oh, amazing! Yeah.
As a difference between the Alpha-3 and Alpha-3 facility edition. The main difference is the motorization, automation of all the procedures which were normally manual at Alpha-3. The two systems are modular. Alpha-3 system is modular to a large extent. Alpha-3 facility edition system is modular to a lesser extent, but still can be upgraded with lots of modules.
Okay. Yeah.
A typical installation of Alpha-3 facility edition consists in getting together the electronics, the mechanics, the optics, and the software.
And also with like computer, like configurations for data storage and the data archiving.
Yeah, exactly. There are two computers. They can be put in place a solution in which a file stored in the acquisition computer is copied instantly with a very great speed on the storage computer.
Okay.
And so in this Alpha-3 facility edition system, we have a motorized emission filter wheel, motorized 6-position detection turrets, objective turret, motorized chamber loader, motorized illumination objective turrets with up to 4 objectives installed in it, motorized illuminators, and motorized XYZ sample stages. And all the crucial part of this system is the software, in which a tracking software is also provided, which means on the fly the system can let you know where the location of the currently imaged zone is located within the larger sample.
Okay.
Can you provide the preview of the sample, of a very large sample?
I see. So you have additional interface, like which shows the macro view of your volumetric.
Exactly.
Yeah, preview before. This is while you are navigating.
Yes.
Before you start imaging, you know where are you going, where you're
Exactly.
looking at, and how you're going to image it.
And the researcher can use a very nice 10x multi-photon objective of evidence to go through the sample,
whole sample.
the whole sample, and they can see the tiny features of that sample, and then return to the previously located portion of that sample.
Very handy. I love this function.
Because of this navigator. And that's why we provide 2 screens instead of 1.
Oh, now I see. Yeah, yeah. So this feature is only limited to facility edition, or it comes with the classic one as well?
Classic ones as well.
Oh, that's good. Yeah,
Yes.
yeah, yeah.
We developed it for the new edition of facility edition, but it can be used with classic one as
Oh,
well,
yeah.
because it was generally very difficult for a user to go back to the region of interest they previously spotted as as the region of interest.
Yeah, because we are talking
We are talking about
Yeah.
getting lost in the very
Yes.
large sample
exactly, yeah.
and knowing the whereabouts of the previously imaged section is a good clue to getting back to it.
Yeah.
And
Very good.
so the sample can be loaded automatically into the bay of the facility edition and put in touch with the objectives, detection objectives. And as you see, we use a multitude of detection objectives here. We
Yeah.
see that we can use the 2x objective, 4x objective, 10x objective, and
Very familiar.
yes,
The objective. Yeah.
and the objective which are equipped with the correction caller.
Yeah, that's good.
And as you can see here with the objectives, we use long distance objectives that can in turn allow us to use a big chamber.
Oh, yeah, I can see. Yeah. So, oh, okay. Correct me. Is that one is the cap you mentioned to protect,
Exactly.
or when you're
Exactly.
using the air objective?
Yes, yes,
Okay.
it's exactly the same. The Teflon cap we are using to protect the objectives from being damaged. And as you see, the objectives are put in touch with the liquid to make a meniscus with this liquid automatically in a meteorized fashion.
Okay. Looks really neat.
And here the scenario of using this system are typically numerous, but one of them is presented here. First of all, the user selects a very low mag objective to measure the whole of the sample, and then they go to imaging detail.
If they find an interest area.
Yes, exactly. And then here, first of all, we a typical scenario is for a researcher to look at the sample, whether the fluorescence is all right, and then go to and this can be done with the transmitted light, with the oculars which are provided in this system, or with the low mag objective, yes, protected by Teflon, and then we go to the imaging of the fine details of the sample with the high mag objective. Like here, if first of all the entire zebrafish can be imaged with 2x illumination and 4x detection. And then the researcher can decide to go into the sample to image the same zebrafish with 10x, localize the channels with the dynamic focus, go to 25x.
Wow, we're a high resolution by 25.
Yes, exactly. And then the whole scenario is to look at the whole of the sample, and then to zoom in on a specific section of the sample with the high-res objectives. It's like visualizing a map wherein you would like to see the entire city and go to a special street in the city.
Oh yeah, yeah.
So this is the same thing, and you see that the zebrafish can be measured in as a whole. We're talking about zebrafish, but it applies to mouse brains, very neat structures inside. Yes.
Yeah, or large clear
samples.
And,
yes.
Yeah, what type of the tissues? Yes. Yeah.
And then as a final node to the system. This can look at the samples of various sizes. Smallest sizes like less than 50 microns, and largest is about like 10 millimeters.
10 millimeters.
Yeah.
10 millimeters. Oh, wow.
Like in this, and the crucial role in this case, crucial role is played with the objectives, and we are very proud to use evidence objectives. And
Yeah, it's a good combination of your technology and the superior optics by us.
Yes.
Yeah, very good. Yeah, sounds very interesting. And then I believe that you have already covered quite a good range of different types of samples, as you mentioned.
Yes.
And then you started having these new facility edition systems and since last year. Yeah, very exciting. So then in this case, I think the next step, I will looking forward for the trainings for the new instrument, and then yeah, very nice presentations, and then thank you so much to
Thank you
giving
so
us
much,
the
and
webinar.
thank you.
Yeah, okay. I look forward to working with you. Yeah,
Thank
again.
you.
Yeah. Thank you, everyone. Hope you enjoy the webinar, and I will keep you posted on how it goes.
Thank you so much.
Thank you.